Friends, today we are going to learn how to run regression, ordinary least square method with the Eviews system. Today we will discuss how to load data on Eviews, how to estimate equations, and how to run a few tests. I have taken the data from NSE site. I have downloaded the data for Reliance for 1 year. For the purpose of this session, I have downloaded the data from NSE website. The data is for Reliance. It is from 1st January 2021 to 31st December 2021. Also the data for Nifty index Nifty50 for the same period, and also the index for oil and gas. Though Reliance is a multi-product company, we cannot link it with oil and gas index only, but for the purpose of this session, I have used the data for oil and gas. Now let us see how we can upload the data on Eviews and how we can work on this. When we start Eviews, we can open the files, new files as work file, database, program, text files. We can also open the files foreign data as work file. Foreign data as work file. Now the file which I have shown you is Excel file. So Excel file is converted into Eviews file by the Eviews software. You can also import the file if it is required. So we will open the Eviews foreign data as work file, or you can directly open the file. I can simply right click it on and I can open it with the Eviews, because start the Eviews. Already the Eviews is already started. You can upload the data directly, or you can simply open it. It will ask you few things, because the first it wants that it should be data should be in date form or month form or quarterly form. So you go on doing this next. So next one, you can see this series. It shows the name of the series, Nifty, ONG, IND, etc. Next, and finish it off. So we have got the data from the Excel sheet to Eviews. Now Eviews has automatically created a variable C, but the C is blank at this time. Similarly, it has created residuals, but this is also blank at this time. You can open it. You can open and see they are not available, not available. Similarly, you can open C. It says it is not having anything, 0, 0, 0, 0. But when we regress it, so we can usually do this. Now we will go to, we can open this data. We can open this data. For instance, you can use control. So it will give me the, you can use the control Reliance, because that is going to be my dependent variable. Then Nifty, ONGINT. So I can open it as, group. I can open it as equation. I can open it as factor, I can open it as var, as a system, multiple series. All these things we will discuss in the coming sessions. So let us open this data as group. So it is as you got in Excel sheet. So we have got the data for Reliance, Nifty, oil and gas, Nifty, this thing. The observations are from this period. Now this Eviews follows the American system. So first is the month, then is the day, and then is the year. Here we can go to quick, and we can also see the estimate equation. Estimate equation, we'll say okay, and first we will write down our dependent variable, then we will write down c is a constant, then we will write down Nifty, that is our independent variable. Let us regress this, and this is the method of least square method. There are other methods also, other methods of regression also, but today we are going to discuss only least square, and the sample period is for this. We will say okay. So now this is our regression equation. So now this regression equation constant is minus 457.7173. Nifty is 0.165812. That is, they are the coefficient. These are the probabilities, and all other things are given here, R square and all. Now let us add. We will delete this equation, and we will go for both the, we will use both the independent variables. Estimate equation, Reliance as your dependent variable, C, then Nifty, and then your ONGIND, that is oil and gas index, which I have taken it up. So we can say okay. Now this is our equation. So this one, C is the constant, standard error is given, then T stat is given, probability is given. Nifty is given, coefficients is 0.1000, and then standard error, T stat is given, probability is given. ONGIND 0.123890, 0.17230. So this is the standard error, T stat. Now this equation can be written. Now see, R square is 0.91. R square is 0.91, and here in this case your F is 1274.570. We can write down the equation in this form. Reliance is equal to minus 249.632 plus 0.1 Nifty plus 0.124 ONGIND. Now the figures in brackets have been given as T stats. Now sometimes people don't write T stats, they write only standard error. Then the reader will have to divide this B with the standard error to get it 10.29. So economists usually write the T stats, but there are some people who have the habit of writing standard error. So you can write down the standard error all as well as or T stats, but you will have to explain in the report that this one, they are T stats or they are standard errors. Now here number of observations 248, R square is 0.96, F is 1274.57. Now T stats are very high. R square is 0.96. This should alert us that there is something wrong in this equation. What is that wrong? That whether we are following the assumptions of regression equation or we are ignoring the assumptions of regression equation. We will go for this in this session only. But what does this equation? Suppose this equation is okay. What does this equation means? When the Nifty changes 1 point, Reliance will change by zero point 0.1 points. Now Nifty, say Nifty has changed 100 points, so Reliance will change 10 points. Similarly, O and G, I and D, if Nifty is static, if Nifty does not change, then as per this ONGIND index, if ONGIND index changes 1 point, then the Reliance will change by 0.124 points. This is the meaning of this. 96% variances of Reliance are explained by Nifty and ONGIND index. F is very high. Now let us see why I say this is a very bad relationship and it is a spurious regression. Let us see what we can do with the Eviews, how we can see whether this is bad relationship. First of all, see the R square. R square is 0.91. See the Durbin-Watson stat. Durbin-Watson stat is 0.13. If R square is more than Durbin-Watson, so it means the regression is not okay. There is problem. Regression equation is not okay. There is some problem. There is some problem. Now T stats are very, very high and probability of rejection of null hypothesis is very, very high, 0.00001. So it means there is some problem. Now, how we can see there are problems? We can go to view, go to coefficient diagnostics and see the variance inflation factor. This will tell us there is a high correlation or no correlation in the variables, independent variables. So let us see this. Now, centered, we will see centered VIF. It is 8.58. It means there is a high correlation. Now, if this value is more than 5, many economists, they ignore it. They say it should be more than 10. But usually the economists say, financial analysts say, this one should be not more than 5. If it is more than 5, it means there is a high correlation among the variables, independent variables. So this is a big problem. How to tackle it, that we will see in the next session. Now let us go to view again. Let us go to view again. Coefficient diagnostic, we can do the coefficient diagnostic by Wald test. Wald test will tell us whether this one, now this, because these variables are C1, C2, C3. So whether this C2, our null hypothesis is whether C2 is equal to C3, C3 equal to 0, whether they are 0. So we will test this. We'll say okay, and it says our null hypothesis is rejected. See the chi-square probability is 0.000. It is rejected. They say it is not 0. C2 is not equal to 0. C3 is not equal to 0. So this is the null hypothesis. C2 is equal to C3 is equal to 0. Now let us see the residual diagnostics, which is very important. That is next one is parallelogram Q statistics. It will tell us, it asks me, how many lags should I include? I'll say, let 36 be there. Now, see, this one, autocorrelation and partial correlation. Autocorrelation, partial correlations, all the observations, they are, whatever they are observations up to 36 lags, they are statistically significant. Lags are statistically significant, but the important one is the first one, and later on it goes on reducing. This is goes on reducing. See the autocorrelation part. Partial autocorrelation, the first one is very important because it the first lag is affecting our model. First lag is affecting our model. Let us go to the next one. Next one, we will see the histogram, that is normality test, whether our residuals are normally distributed or not. Now see the normal distribution. It appears to be normally distributed. But there are some gaps somewhere. So, but if you see the Zark-Bera statistics is 5.489957 and the probability is 0.06, but it is more than 0.05. The null hypothesis is the normally data is normally distributed and data is not normally distributed. Zark-Bera also says at 5% significance level, data is not normally distributed. We will go to view again and we will go to residuals diagnostic. We can see the serial correlation in the residuals. We will again take the two lags, and in the serial correlation, the null hypothesis, there is no correlation, serial correlation, but our C F statistics and then probability chi-square 2 is 0.000. We reject the null hypothesis. There is a serial correlation. We can see this F statistics and observed R squared and then probability chi square 2. This probability chi square 2 is only tells us whether there is, this test is called Brush Godfrey serial correlation LM test, whether the data residuals are serially correlated or not. Then we can do the again heteroscedacity test. Heteroscedacity means this test is also called Bresson Pagan Godfrey test, and we say okay. And this one also says null hypothesis. In this case there is homoscedacity, means variance throughout is constant, but this one 0.08, 0.1908 chi-square values are this. So we cannot reject the null hypothesis. We cannot reject the, because the values are 0.04. So we can say there is still homoscedacity. That issue is not there. So we can see the test, we can work on this test, because there are many issues like your R square is very high, there is no this one is serial autocorrelation is there, there is multicollinearity. So that is why we say this is a very bad relationship, as it is a spurious regression. We will talk more on regression issues through Eviews, and I will explain you more tests and how we can handle the assumptions of regression in coming videos. Thanks for watching. More videos are coming up. I request you all to subscribe to the channel. Thank you very much. You may submit your research work at Journal of Global Economy, rcssindia.org. Your work is evaluated by peers with double-blind methodology. You will get comments for your work. Thank you.